maybe something else, maybe a scientist, maybe an engineer, maybe a doctor, uh, maybe something else also. I don't know. ನಿಮ್ಮ ತಲೆಯಲ್ಲಿ ಏನಿದೆ ಗೊತ್ತಿಲ್ಲ. ಬಟ್ ಅದಕ್ಕೆ ಏನು ಇನ್ಫಾರ್ಮೇಷನ್ ಬೇಕು ಅದಾಗೋದಕ್ಕೆ? ಸೊ ಟು ಪ್ರೊವೈಡ್ ದ್ಯಾಟ್ ವಿ ವಿಲ್ ಹ್ಯಾವ್ ಅ ಸೆಷನ್ ಆನ್ ದಿ ಕೆರಿಯರ್ opportunities, what all you can think of, and plan accordingly. Okay, and this information is not only for students, but this is more for parents. Okay, so career session part ಏನಿದೆ ಅದು ನೀವು ಬುಕ್ಕು ಪೆನ್ನು ಇಟ್ಕೊಂಡು ನೋಟ್ ಮಾಡ್ಕೊಳ್ಳಿ, ನಿಮ್ಮ ತಂದೆ ತಾಯಿಗೆ ತೋರಿಸಿ ಅದು. ಓಕೆ, ಆ್ಯಂಡ್ ಎನಿವೇ ದಿ video is being recorded, that will be shared at some point, so that's not a problem. Okay, fine. Now the first session is going to be on, I said, two very basic aspects, correct? So those two basic aspects will correspond to one, time, two, distance. Okay, ಸೊ ನಾವು ಜನರಲ್ ಆಗಿ ಯಾರೇನು ಕೇಳಿದ್ರು ಟೈಮ್ ಇಲ್ಲ ಟೈಮ್ ಇಲ್ಲ ಟೈಮ್ ಇಲ್ಲ ಅಂತೀವಿ ಅಲ್ವಾ? ಏನು ಮಾಡ್ತಾ ಇರ್ತೀವಿ ಅಂದರೆ ಗೊತ್ತಿಲ್ಲ. ಅಜಿತ್ ಆ ಪ್ರಿಂಟ್ಔಟ್ಸ್. ಸೊ ಏನು ಮಾಡ್ತಾ ಇರ್ತೀವಿ ಅಂತ ಮಾತ್ರ ಗೊತ್ತಿಲ್ಲ. ಏನು ಮಾಡ್ತಾ ಇರ್ತೀವಿ ಅಂದರೆ ಟಿ ವಿ ನೋಡ್ತಾ ಇರ್ತೀವಿ, ಅಲ್ಲೆಲ್ಲ ಆಟ ಆಡ್ತಾ ಇರ್ತೀವಿ, ಮೊಬೈಲ್ ನೋಡ್ತಾ ಇರ್ತೀವಿ, ಇನ್ನೊಂದು ಮತ್ತೊಂದು ಇದೇ ಆಗುತ್ತೆ, ರೈಟ್? ಸೊ ಲೆಟ್ ಅಸ್ ಸ್ಟಾರ್ಟ್ ಬೈ ಡಿಸ್ಕಸಿಂಗ್ ವಾಟ್ ಇಸ್ ಟೈಮ್. ಆ್ಯಂಡ್ ಐ ವಾಂಟ್ ದಿ ಸೆಷನ್ಸ್ ಟು ಬಿ ಇಂಟ್ರಾಕ್ಟಿವ್. ನೀವು ಕ್ಲಾಸಲ್ಲಿ ಕೂತ್ಕೊಂಡ್ರೆ ನನಗೂ ನಿದ್ದೆ ಬರುತ್ತೆ, ನಿಮಗೂ ನಿದ್ದೆ ಬರುತ್ತೆ, ಇಬ್ಬರು ಮಲ್ಕೊಂಬಿಡ್ಬೇಕು. ಎ ಸಿ ಬೇರೆ ಹಾಕಿದ್ದಾರೆ ಅಜಿತ್ ಸರು, ಇನ್ ಫುಲ್ಲು ಡೀಪ್ ಸ್ಲೀಪ್ ಏನೆ, ರೈಟ್? ಸೊ ಐ ವಾಂಟ್ ಇಟ್ ಟು ಬಿ ಆ್ಯಸ್ ಇಂಟ್ರಾಕ್ಟಿವ್ ಆ್ಯಸ್ ಪಾಸಿಬಲ್. ನಿಮಗೆ ಏನೇ ಕ್ವಶನ್ಸ್ ಇದ್ದರು, ಏನೇ ಡೌಟ್ಸ್ ಇದ್ದರು, ಅಥವಾ ಇದು ಕೇಳಬೇಕು, ಕ್ಲಾರಿಫೈ ಮಾಡ್ಕೋಬೇಕು ಅಂತಿದ್ರೆ ಇಮಿಡಿಯೇಟ್ಲಿ ಯು ಶುಡ್ ಸ್ಟಾರ್ಟ್ ಆಸ್ಕಿಂಗ್. ಯಾಕೆ ಅಂದರೆ ನಾನು ಇಲ್ಲಿ ಯಾವುದೋ ಪಿ ಪಿ ಟಿ ಎತ್ಕೊಂಬಂದಿಲ್ಲ. ಓಕೆ, 10 ಸ್ಲೈಡು 12 ಸ್ಲೈಡು ಪಿ ಪಿ ಟಿ ಎತ್ಕೊಂಬಂದ್ಬಿಟ್ಟು ನಿಮಗೆ ತಲೆ ಕೊರಿಯೋಕ್ಕೆ ಬಂದಿಲ್ಲ. ಬಟ್ ಐ ಆಮ್ ಹಿಯರ್ ಟು ಗಿವ್ ಯು ಪರ್ಸ್ಪೆಕ್ಟಿವ್, ಅನ್ ಐಡಿಯಾ. ಓಕೆ, ಸೊ ದಟ್ ಮೀನ್ಸ್ ಐ ವಿಲ್ ನೋ ಇಫ್ ಯು ಆರ್ ಗೆಟಿಂಗ್ ಎನ್ ಐಡಿಯಾ ಆರ್ ನಾಟ್ ಓನ್ಲಿ ಇಫ್ ಯು ಇಂಟ್ರಾಕ್ಟ್. ಫೈನ್? ಓಕೆ, ಸೊ ಲೆಟ್ ಅಸ್ ಸ್ಟಾರ್ಟ್ ಬೈ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ವಾಟ್ ಇಸ್ ಟೈಮ್. ವಾಟ್ ಇಸ್ ಟೈಮ್? Probably I should start pointing out. What is time? Time is something which does not wait for us. Okay. That could be one definition. Yes? Time is? It's a fourth dimension. What do you mean by dimension? So like length, breadth, height, you're saying time is another dimension. Okay, good. Sit down. Anybody? Anything else? What is time? Yeah. You have time in the definition of time. Huh? So it's something which does not stop. Okay? Anything else? Time is? How precious? Oh, okay, in that sense. Okay. Precious than any costly thing. So you want to fix a price to it and say it's priceless. Right? Okay. Next. You're all telling me properties of time. But nobody is telling me what is time. Time is priceless, agreed. Time doesn't stop for anything or anyone, agreed. Time is a fourth dimension, agreed. They are all the properties of the time or the nature of time, right? For example, if you ask me, which is the fastest train? I would say bullet train. I will not say the train is so long, it has so many windows, right? That becomes the property of the train or characteristic or nature of the train. But the question is, what is time? Out of syllabus questions, sir, idu. Correct? Yes. You live in time, is it? That's what you're trying to tell. It's not a physical entity. Okay? That pretty much kind of is an explanation or elaboration of what he said. Time is a dimension. You live in a dimension, right? Okay, not a problem. So what is time? 40 ಜನ ಇದ್ದೀರಿ, 4 ಜನ ಆನ್ಸರ್ ಕೊಟ್ರಷ್ಟೇ. ಇನ್ನು 36 ಜನ ಯೋಚನೆ ಮಾಡ್ತಾ ಇದ್ದೀರಾ? ಹಾಂ, ಎಸ್. Time is a value which keeps a record of events. So if I say it is 10 a.m. now, what event is it recording? Oh man, you touched me. Good, okay. This is a very, very basic question, right? And this is something that people have been trying to ask and answer, not today, but for centuries. Okay? In reality, we actually cannot give a physical definition for time. Okay? For example, another example. If I keep, or if I ask you, what is your favorite breakfast? What would you say? Huh? Masala dosa, very good. True Bangalorean, man. So if I ask you what is masala dosa, what will you say? Don't say it is dosa, sir, or it is type of dosa. That is fine. That is the answer that you have given. But the question is, what is masala dosa? Correct, it's a food. Right? It's a type of food. Then probably you will explain how it is made. You take tawa, do chus, then put dosa hit, then all that you will explain. Correct? So, any physical entity will have certain definition which goes by its nature or characteristic. Like the bullet train, like the masala dosa. Something else, if I ask you how does HN all look, or where is HN all, or what is a laptop, what is a mobile phone. So you have answers to these questions because it is physical and it is tangible. You can hold it in your hand, right? Of course, bullet train you cannot hold in hand, but at least you can go and touch it physically, right? Or model you can hold at least. So anything that is physical and tangible, based on its characteristics or physical properties, you can give a definition or use those properties to characterize a physical entity. Unfortunately or fortunately, time is such an entity which does not either have physical properties, it is not tangible, you cannot touch, feel time, right? And hence, what exactly time is, nobody knows. But we have been using time, right? All of you said there are so many properties of time. So then how do we assume or how do we presume time? Or how do we know time basically? Clock, watch, clock, watch ಎಲ್ಲ ಒಂದೇ ಕಣ್ರಪ್ಪ. ನಾವು ಸ್ಮಾರ್ಟ್ ಫೋನು, ಮೊಬೈಲ್ ಫೋನು, ಆರ್ ಗ್ಲಾಸ್, sundial. So you are using an instrument, correct, to measure something which we are calling as time. And most of these instruments that you are explaining right now are instruments that are based on naturally available materials or nature in sim, correct? If you actually go back to the origin, probably when we were all cavemen and then, we just evolved from apes to cavemen, if you believe in Darwin's theory. How many of you believe in Darwin's theory? Or how many of you know what Darwin's theory is? Okay. So many of you haven't heard what Darwin's theory is. Okay, fine. So there was this scientist called Darwin. Okay. So what he said was that he did an extensive study in an island called Galapagos Island. Okay. And he could see most pristine form of life forms there, which was undisturbed for millions of years. And when he was making these observations, he noticed that there are certain properties that convey a message to us. That message is that we humans, or the Homo sapiens as we are called, evolved from monkeys or primates. Not exactly monkeys, but we should call them primates, okay, or apes. Okay. So he gave a brief, not brief actually, a detailed explanation of how exactly every form of animals and birds and living organisms that you see on earth today has evolved from something which was in a different shape, size, structure, etc. Okay. So that is Darwin's theory of evolution. We have evolved from something to something else, to the form that we are taking today. That's why there is a saying also, no, ಮಂಗನಿಂದ ಮಾನವ ಅಂತ ಕೇಳಿದಿರಲ್ವಾ, ಕಾಮನ್ ಅದು. ಅದ್ಯಾಕೆ ಕೋತಿ ಥರ ಆಡ್ತೀಯ ಅಂತ ಇರ್ತಾರೆ ಮನೇಲಿ. We have come from them, so there is something, a bit of DNA. Parents will agree. So there is a bit of DNA, yes. Correct. That's why what happens is, a lot of times when there is translation, correct, you have something in a particular language which you use to define as a common language, and then you translate it into another language, maybe for regional reasons or better understanding, etc. Sometimes what happens is, when you translate, there is no literal translation. Okay. So many words in science, that is a challenge. Although there is one meaning in English, there is a totally different meaning in, say, Kannada, for example. And in Kannada also, although it is used for one reference, but it could have multiple references. So you are right when you say Koti is equal to monkey, but monkey is not equal to ape. You're perfectly right. But easy understanding of ape in Kannada is Koti only. Okay. Although there are other words which we can use, but it becomes too technical. Common people don't know. So that is a challenge. That's a problem. Anyway, let's get back. So since the time we have been evolving from caveman, Iron Age, all those things, we have been keeping track of time. We have been measuring time. How? Any guess? Very good. The simplest and easiest form of timekeeping is look at the sun. Okay? So sun rises in what? East? Sure? 100%? How many of you think it is east? No, it's okay. If you don't agree, you need not agree. But you have to tell me why you don't agree. So all of you agree that sun rises in the east. What? It's okay. How many of you think it does not rise in the east? Why? Oh, okay. She is going too factual. That is okay. But even otherwise also, let us assume for a minute that, sun rises. From the point of view on earth, from us standing here and looking at the sky, we see sun rises, right? So even then, how many of you think sun does not rise in the east? I can agree to that. Sir, you are standing on the other side, so you will raise your hand. Your textbooks are partially right in telling you, and your teachers have been forcing you to mug this up, as question and answer. Where does the sun rise and set? Sun rises in the east and sets in the west. That is the question and answer you have been mugging up for years. But the actual truth is sun rises in exact east and exact west, sets in exact west, only 2 times a year. Only on 2 days in a year, sun rises exactly in the east and sets exactly in the west. On all the other days, sun actually rises away from the east and sets away from the west. Okay? Sun rises exactly in the east and sets exactly in the west on what is called as solstice. Okay? Yes. Write it down, go look up when the solstices are. September 23rd, right? And yeah, when is it? When is winter? Somebody told. He said September. He said September 23rd. So 23rd, 24th September. Summer. Calculate 6 months from the date. No. Simple. Okay. Fine. So that will be your assignment number 1. You need to figure out when solstices are, and there is something also called as equinox. Okay. So you will find out these dates. When are the equinoxes? When are the solstices? Okay. And on all the other dates, sun actually rises between northeast and southeast and sets in southwest and northwest respectively. If the sun is rising in the northeast, he will set in the southwest. If the sun is rising in southeast, he will set in the southwest. Okay? Why? Do you know? Can you guess? Okay. Okay. No. Although there is something called as wobbling effect, there will be slight displacement. It's not like sun is shaking like this, like this, like this. Earth is shaking like that. There is slight wobbling, but that is not the reason. This is again something you have studied in your class 5, 6, 7th in, not in science, but somewhere else. But that causes day and night and seasons, no? That's what your geography book told you. Correct? Am I right? Okay, I remember my classes very well. No. Very good. The earth is not perpendicular to the orbit, right? So the orbit that it goes around the sun and the axis on which the earth rotates, these two are not perpendicular to each other. There is a slight tilt of, by how much? 23.5 degrees. Correct? This is again 7th, 8th standard geography textbook. So your earth is tilted by how much? 23.5 degrees, which means Earth is rotating like this, not like this, spinning like this. Because of this reason, sunrise also moves away from the east towards northeast, comes back to east, goes towards southeast. Similarly, setting happens in southwest, moves to west, goes to northwest, and comes back. Okay? This is an experiment that you all can do. All that you have to do is, if you have a camera at home, or your mobile phones are also fine, and most of you, I think, would have stands also to put your phone, tripods and all. All that you have to do is fix up south, east or west, whichever is visible in your balcony. Okay? And from that place, fix a time. Say 6 o'clock in the morning or 6 o'clock in the evening, whatever, whichever is convenient. For 15 days, all that you have to do is get up exactly at the same time, somehow or the other. Whether you take your milk, brush your teeth, doesn't matter. Go to that position, exact frame, click a photo of sunrise or sunset. Do it for 15 days or even 10 days. You will notice the sun does not rise and set in the same place. Okay? And this is something that your textbook doesn't tell, unfortunately. Correct? Sun always rises in the east, sun always sets in the west. And you go ask your teacher, they will shout at you. Textbook alli ilde irodella kelbardu neevu. Right? Okay. So, coming back to the time, the sunrise and sunset have been the most important aspects of timekeeping. Okay? And using them, there have been many instruments that have come up. Somebody said sundial, right? So sundial is one of the simplest and easiest time-keeping instrument or time measuring instrument. It is not time. Do you understand the difference? Sundial or your clock, your watch, your mobile phones, anything, gives a measurement of time, but it is not time itself. Fine? So why am I talking about this? Why am I talking about something so very trivial? ಬೆಳಗ್ಗೆ ಎದ್ದಾಗಿಂದ ವಾಚ್ ನೋಡ್ಕೋತೀವಿ, ಫೋನ್ ನೋಡ್ಕೋತೀವಿ, ಟೈಮ್ ಹೇಳ್ತೀವಿ. So you have to remember, a lot of physical quantities or physical measurements are dependent on time. Especially all of you are probably going to continue in science, right? For your 10th and then 11th and 12th. How many of you are going to go for arts or commerce? Very good. Very good. Arts or commerce? Why? Teacher of what? So why arts for that? You can't become a teacher by studying science? No. Then what am I doing? What was Kamala ma'am doing? What was Janvi ma'am doing then? Which subject do you want to teach? In Montessori also? Anything is fine. Okay, what about you? Oh, you want to do CA? Because it's lucrative. Huh? Why do you want to do CA? Okay, no problem, but still, why? Science is complicated. Why do you feel so? Okay. You're finding some difficulties in learning it. So you feel, why even bother? Let me take something else. But one thing you're forgetting, whether it is science or CA, you have to deal with numbers only. Right? Okay. So, whenever you are talking of any scientific measurement, regardless of whether you will do science, commerce, arts, something else, pottery, anything and everything, the first and foremost thing that you need to do is look at the time, measure the time, and hence, measurement of time is one of the most crucial aspects And especially those of you who are going to do science, time is something that will keep on haunting you multiple times. You say velocity, you say speed, you say time, you say something else. Everywhere you will see time. Okay? And unfortunately, you also, I mean, kids these days, when we were your age, we were not using that, but kids these days also make statements. My time is not good. I'm getting scoldings from my parents, from my teacher. My time is not good. My best friend who used to sit next to me in the bus is sitting with someone else now. Correct? You have made these statements. Ah, yes, sir. Very good. So I'm updated. I'm not old also. Okay. So for this reason, I thought we'll discuss something about time and how time has been used or measured from a very long time. This is not something new. You have already studied in class 7. But the reason why I'm trying to come here and tell you this again is to give you a different perspective. Okay? Time should not be just looked at as something that you see, that you read out of your phone or clock, but it is an important unit of measurement. Okay? Starting from the simplest unit of measurement, what is that? What is the simplest unit of measurement? Huh? Centimeter? Second, okay. Okay. You're in a different plane altogether. What did you have for breakfast? Okay. I think that is the idli speaking. What did you have with idli? Ah, see? That makes sense. That Taurus is making you speak so much. Oh, okay. Not the constellation Taurus. It is the shape. The shape is called Taurus. Taurus. Not Taurus. See, that is the problem with English. Anyway, so right from minutes, which is what we probably use regularly, we don't say seconds. Will you say I'll be here in 1 second? You'll say I'll be here in a minute. Right? You know 1 second will go like this. Okay? From minutes, of course there are lower orders, up until say measurements like years. This is something that we regularly use. Okay? But beyond that, time can also be measured using different units. It can be measured using seconds, milliseconds, microseconds, nanoseconds. Beyond that, you can also go up to using centuries. Okay, very good. Then, huh? Eons, decades. Huh? Sorry? Fortnight. Okay. Then, somebody said something. Millennial. Right? Yes? Millennium? Yes? Very good. That is what I wanted to hear. What is it? Unit of distance and not time? Right. Light year is measure of distance, not time. I was waiting, somebody will say light year, light year, light year. Somebody said it, that's okay, that's not a problem. This is a common confusion that people have because it has years in it. So people think it's a measurement of time, but it is a measurement of distance. Okay? So now what we will do is enough of me talking and giving you all gyan. We will build a simple sundial. Okay? This is a simple, just one moment. Okay, so this is a simple origami based sundial. Okay, how many of you know how to read sundial? Physically? Okay, good. So that means most of you are not completely aware of how to read a sundial, right? So what we will do is we will build this sundial. Okay, so I think I'll circulate few. Take one and pass. I'll tell you how to do that, but for the moment you just take this and pass. Okay? And because I want my session to look fancy. I will also play some video which clearly explains how sundial works. Okay? So what you are seeing here is a typical sundial. Sundial usually has minimum of 2 parts. All of you have gotten the sheets? Okay, keep, come, take. So keep those sheets aside for a minute. All right. So sundial typically has 2 major parts. The first part is a sphere or a circle, like you're seeing in the video, which basically has some markings. Okay. So these markings correspond to so-called time, or they basically have numbers on them. Okay, and they are divided in a specific manner or specific fashion. Even when you look at the sheet that is given to you, right, you will notice that there is a semicircle, and on that semicircle, it's not a perfect semicircle, it's slightly little over the semicircle, but that's okay. What is it called? Sector or secant? Sector? Okay. So you have, has everybody got? Yeah? If you have extra, please leave them. Okay. So that also has some markings, and those markings are not uniform. There is a particular way in which the marking has been done. So there is a reason for that. I will explain that reason. So the first part is that. And the second part is what is called as the shaft or gnomon. Okay? Gnomon is with a G. So it starts G-N-O-M-O-N. That is the spelling. Okay? So these are the 2 parts of a sundial. Technically what happens is you have that round structure or a spherical structure, and at the center of that you place the shaft. Okay? In this image that you are seeing and the video that I will play, the shaft is not perpendicular, but it is inclined at an angle. I will tell you the reason for that also. But for the moment, let us just assume there is a shaft that is perpendicular. So now what happens as the sun rises and sets, you know, it casts a shadow, and as the sun casts a shadow, that will fall on to the circular dial that we have created. And as the sun moves in the sky, the shadow also moves. And based on that shadow, you will be able to tell the time. This is something that you have already read, class 7, correct? Now, 2-3 things are important here. Number 1, why do we have to have a shaft? Anyone? Correct. If we want to use shadows to read the time, we want something to cast a shadow. So this shaft plays the role of that. The only role that the shaft has is to cast a shadow. Okay? Now, in this video, if you are seeing, the shaft is bent, right? You can see. It is like somewhat a bent structure, not straight like this. The bent structure signifies, I don't know how people in those times were able to guess, it actually signifies the latitude of a place. Why? Because, you know, as the earth is tilted, the sunrise and sunset at different latitudes is going to happen at different times. As in overall. Sun rises at 6 or 6:30 everywhere locally. But locally 6 a.m. does not mean 6 a.m. elsewhere. Right? Correct? And hence, because of the tilt and latitude, we need to account for that also. For example, if you are here in Bangalore and you have a friend who lives in Delhi, things are okay because sun rises say at 6:15 in Bangalore, sun rises at 6:13 in Delhi, so not a problem. But what if you have a friend here, you are here and your friend is in Australia or Japan or in US, and then you want to talk, you want to WhatsApp or Skype or whatever, now Snapchat, no, you're all not aware of that. Okay, good. So these are the issues with timings. So to account for that and the change in the latitude, usually this shaft that you are seeing or the gnomon that you are seeing is aligned to the latitude of the place. How did they guess the latitude of the place? Any idea? Because they did not have geography, they did not have protractors like how you have to, measure angles and say latitude of the place is so much. How do you think people guess the latitude of a place? Huh? Sunrise happens in east and sets in west, no? Wherever it is. Time also we don't know, right? North and south, north will be in north, south will be in south. If you can identify east and west, very good. Yeah. Sorry? Equinox, okay. So yes, equinox is one way of measuring, but the most easiest and simplest way of measuring is by looking at stars. Okay? Especially something called as the pole star or the Polaris, right? Did you have or did you listen about Polaris or pole star when in Science Utsav? You did, right? So that is a star which points at the north, it doesn't rise, it doesn't set, it's always there. You have heard all that. So by looking at this direction of this pole star, you can fix the latitude of the place. And based on that, you will be able to measure a time that is locally right. If you have a shaft that is standing perpendicular like this, then this doesn't account for the curvature of the earth or the latitude variation. So you will not be actually measuring perfect time. So it is always appropriate to have your gnomon inclined towards the latitude of the place. In fact, this fact that the change in latitude casts a different shadow was used by somebody. Who? Again, this was in geography, I guess, class 6 or 7. Egyptians, okay, but there was one person. Huh? You remember this guy, Eratosthenes? No? You remember somebody measured the diameter of the earth? Huh? Who? His name is Eratosthenes. Eratosthenes. There is something longer, but that's what it's pronounced as. Okay. So what he did was he measured this variation in the shadow and then used that to determine the curvature of the earth and hence the diameter of the earth. Okay. So that is the reason why your gnomon is always inclined towards the latitude of the place. Fine. I think working you all know. Maybe I'll play the video, you can explain. One of you will explain what is happening here. You will also keenly observe, if you want I'll play it again. You will also tell me where is the sunrise, sunset, all those things. Do you want me to play it again? Okay. So now, where is sunrise and sunset happening? One of you should come here. Sitting and talking there, I cannot hear. They have put something. This is even more troubling. Ah, who will come? Come. Good.
So the sunrise is happening that side.
One moment, one moment. Okay, yeah.
The
Go
sunrise
on.
is happening that side. So the shadow is casting this side.
Okay,
Because now we can see the shadow over here.
okay.
So the sunrise is this side.
On to your right.
No, opposite of the shadow.
Correct. That means towards your right. Your right, right? While you are looking at it. Okay, what is the time it is reading now?
It is reading 11:40 near 11:30.
Okay, 11:30, 11:40. Okay, good. So, okay, thank you. Good. So, in what direction is this sundial placed? Who will tell me? You have to come here. You can walk up here. Come, come, come. Come. You're shy for that. Then come. So you just have to tell me the cardinal directions. That is, where is north, south, east, and west? Go there, go there.
North, south, east, and west.
So that is north.
Yeah.
This is south.
Yeah.
This is east.
Yeah.
This is west. Sure?
Yeah. I think.
Okay. Anyone else want to take a guess? Please, thank you. Anyone else wants to take a guess? I have given enough clues, so if you haven't yawned, if you haven't felt sleepy, you would have guessed it by now. ಹಿಂಗಂದ್ರೆ ಹೆಂಗೋ? Where is north, where is east, where is south, where is west? North to south, you have to come here. The gnomon is facing north. How many of you agree to that? How many of you are not sure? How many of you don't know what is happening here? Okay. So yes, the gnomon is actually facing the north. That's what I told you, right? You place it towards the latitude of a place, and you can identify the latitude of a place by looking at the North Pole star. So this is kind of inclined towards that direction. So the time that it is reading is roughly 11, between 11:35 and 11:40, right? Okay. And remember, like I was telling, there were other instruments that were also used to measure time. Okay. Another most important instrument that was used, of course, somebody said sand clock was being used, of course, but I'm not going to show you sand clock, but I'll show you another one that was being used. Okay, this is what is called as a water clock. Okay, so if you see, look at the video, I'll explain the video later. Just pay attention to the video. Of course, the water clocks don't rotate technically, but they are showing you the rotation just to give you an idea. Okay? So if you paid attention, There are certain holes here, right? Let me freeze the video for a moment. Okay, so you can make out these holes here. There are vertical, there are horizontal also. So these holes are etched or made at certain specific locations in that cylinder. Okay, so there is a reason for that. That tells you the actual time, 1 o'clock, 2 o'clock, 3 o'clock, so on and so forth. That holes does not kind of take away the water from it. It just are markings that tells you the time. Okay, and if you look at the bottom, when I play the video, probably you will notice that the water is dripping from the bottom. Correct? Fine. So you have a cylindrical structure. There are markings inside of the cylindrical structure which are decided based on the dimensions of this cylinder that you are taking. And at the bottom there is a hole through which the water is dripping onto something much bigger and the water is flowing out. And by looking at it, you can count what is the time. Okay? Now, go ahead. Take the photo. So the question is, why did I choose water clock against sand clock? Yes. Why do you think I chose water clock to discuss water clock against sand clock? You know, the hourglass that you would have regularly seen. The reason why I chose this water glass is to give you a piece of information that probably most of you cannot connect to. Okay? Now, the connection, before I give you the connection, how many of you go to temples? All of you. Because your parents force you to. Yes, sir. If you are given a choice, you don't want to. How many of you are like that? Why? You think it's boring. Okay? Why? You don't believe in God, or you don't believe in going to temple to? You don't believe in God. Okay? Fine. Who else? You don't believe in God. Okay, so those who don't believe in God, why don't you believe in God? Just to get a perspective, I'll come back. Okay. Okay, so you are saying probably not gods, but their teachings. Okay. Okay, good. Yeah, please, please, please. You're most open to say anything you want to. Mm-hmm.
God is there or whatever, or it's her interest to go to visit the God. Maybe she feels bored because there is nothing innovative to see there. I think the temples should be more creative. They are already creative, amazing structures and stuff. We visit big temples, but it's like too clumsy and messy also, which makes them uncomfortable and coming to the boat girl.
Mm-hmm.
So there's a difference between so, see, okay. What do you mean by like believe in God? You pray for them, and you think that should happen, and if that doesn't happen, so you don't believe in God, or what is the real reason? What was the impact it had on your mind? Like there are many bad
What these, both of these, sit down. Both of these girls, what their meaning is, you pray to God and you want God to give so many things, but and you do so many puja, invest in things and all those things, but still there are so many bad things are happening. So if there is God, why are bad things happening? Right? That's your question. Parents, do you have an answer to these questions? I see two parents. So you are saying it is most of a psychological aspect, something in the mind. Okay. Ma'am, you wanted to say something?
Actually, that is that they don't believe in it. So God, we can't say that the shapes of the God would be like Brahma Vishnu. It's a supernatural power. It's a light. So however we take whether it is a negative way, it becomes in a negative way only. So if it is in a positive way, we gain positive energy. It's like a supernatural power.
Great. Thank you,
Now
ma'am.
we accept the thing is the way. As of which way we go, the way we get it.
Great, great. Thank you.
About the temples, I said I don't like going to temples. That is because people say God is everywhere, God is everywhere. Why do we need to visit the temples when there is God everywhere?
Good. Great. The problem is, let me tell you the core problem. Your parents push you to do things. Am I right? But they don't reason you out. Right? Simple answers to your questions that I think, from my point of view, I might be completely wrong, and there is no compulsion on you to agree to whatever I'm saying. Okay? You can object to what I'm saying, you can object to not agree to what I'm saying also. Temples are places of worship, even though God is believed to be everywhere. Answer to that question is, when you can study at home, why should you go to school? You studied at home? 2 years of pandemic, online classes, pass the exam, you learned something. Why do you have to go to school? Good. You need a place, sit down, sit down. You need a place where like-minded people can come together, deliberate on common points. Temple plays that role. Okay? Next, temples are boring, there is nothing, it is not offering anything new to the new generation people. No, that is a point, that is definitely a point. Why should it offer anything new to you people? Have you understood everything that is already existent in temples? If you enter a temple, there is a gopura. You know why there is a gopura? They always ask you to go around the idol in a certain way. Do you know why it is done? Have you found answers to these questions? Yes or no? We haven't even asked these questions, sir. Correct. So there are many aspects that are still not understood by us. So once we have understood that, then we have the right to question things. Without you doing problems, the homeworks that your teachers have given, how can you go back and say the question is wrong, the answer is wrong? Correct? Right? Coming to the other part, bad things, all those things. I'm not going to get into that right now. We can have a discussion later. But why I came to the concept of gods is not to discuss philosophy, but there is too much of science in a temple. And that is something that you people should be keen on observing. One thing, like somebody was telling, the ma'am was telling that about, you know, the way we go around temple, structure of the temple, the dimensions of the temple, the dimensions of the idol. These are all scientific facts. Belief is a secondary aspect. Whether you believe in God, whether you believe in a particular form of God, is a belief system. But temple itself is an architectural marvel, wherever it is. How many of you have visited Shiva temple? Ishvara, Shiva, something? Where there is linga, not the idol, but linga. Most of you have. The common view in a Shiva temple is on the idol you will see a structure where water is poured and always dripping. Have you asked what that is? No? Huh? ಅಭಿಷೇಕ ಕರೆಕ್ಟ್, ನೀರಿನ ಅಭಿಷೇಕ ಯಾವಾಗಲೂ ಮಾಡ್ತಾ ಇರ್ತಾರೆ. ಯಾಕೆ ಅಂತ ಕೇಳಿದ್ರೆ ಶಿವ ಅಭಿಷೇಕ ಪ್ರಿಯ ಅಂತಾರೆ. ಬಟ್ ದಟ್ structure that you are seeing, which is placed on a Shiva idol, which is always dripping water, is actually a water clock. It is a water clock that is called as Ghati. Ghati, Ghati. Or you would have heard the word Ghata, right? So it is what is called as a Ghati. It is a water clock, which we have been using for centuries, even before others started using water clock. Now the question is, why is it put on Shiva's head? Correct? Why did they choose Shiva to put it? Answer is very simple. Temples were the places of learning, right? And water clock, if you pay attention to, ನೀವು ಗಮನಿಸಿದ್ರೆ ನೀರು ತುಂಬಿದ ತಕ್ಷಣ ಹರಿದು ಹೋಗುತ್ತೆ after some time. Somebody has to refill it, no? For example, if I put it in this corner and go, the water will run away, and then who is going to refill if nobody is paying attention to it? But if it is a temple where there are students who are learning, where there are teachers who are teaching, there are people who are visiting it, somebody will notice it. Somebody will inform somebody else to refill it, right? So the Abhisheka bowl that you see on Shiva's head is a water clock called Ghati, and the dimensions of the Ghati tells you the time. There are different sizes of Ghatis that can be built based on the time. So there is Ghati that can run for 1 hour, 2 hour, 15 minutes, whole day, so on and so forth. The dimension of that Ghati, the size of the hole through which the water should drip, it is all determined by mathematical calculations based on division of time throughout the day. This is why you should visit temples and ask questions. Why this is the way it is. Okay? That is why I brought in this idea of gods. Okay? Not to discuss any philosophy. Let's not get there again. Okay. So now what we will do is, we have this sundial with us. So let us build this sundial. Okay? It is a very simple thing. So what we will do is, we'll quickly cut along the outline, or you need not cut along the outline also. Can someone give me a scale and scissor? Thank you. Give me a scale. Great. So the only thing that you are supposed to do is squeeze along 3 lines. I'll tell you those 3